This is what's known as the finishing problem with method chaining. The problem here is my rules.add, when I call add, if I try to persist this or anything else, none of this other code is actually executed yet. So it hasn't finished yet. And I really want it to finish at the proper time. Now I could solve this problem by always ending it with something like .save. But I don't want to do that because it hurts the fluency of my DSL. Normally when you're having a conversation with someone, you don't say, yeah, let's meet for dinner at that place we ate that time, save. You usually don't have to say that in conversation, and it's kind of cumbersome to have to do that in DSLs because that's something you have to remember to do, and of course you'll forget it and then try to chase down a bug. That's why it's not actually saving, and so that's not what we actually want. What we actually want is to use not just purely method chaining, but also nested methods. So what we want to do is rewrite our rule list class to look more like this, where my add method takes a discount as a parameter. Now I can construct that discount based on customer profiles and all that other stuff within the context of those parens. And I know that by the time I get to the actual body of this method, all that stuff has been created. In fact, it would look something like this. So now my rules.add is no longer chained method. It's actually creating, using as a parameter. And notice all this stuff, I'm using the Fluent interface to build all this stuff inside the parameter. In fact, that's the end of the parameter parentheses. But all of my add stuff now works correctly because now I've given it a wrapper context that says, okay, once you've done all this stuff, then put it out or put it in the database or whatever you're going to do. And in fact, a general rule of thumb when creating this kind of Fluent interface is to use method chaining for stateless object construction. Notice that my profile and my discount were essentially stateless objects. In other words, that it didn't really rely on a particular ordering of how you call the methods, and there was no specific ending criteria for those guys. You could pretty much do them in any order that you wanted to. And then use nested methods to control completion. Use nested methods to create a wrapper around things that you want a specific wrappered context for example, saving. Okay, I'm going to stay in this same bakery theme and talk for a bit about recipes. What I want to do is create a Fluent interface that allows me to express recipes. And here's my goal syntax. I want to be able to say something like recipe.new and then recipe add 200.grams of flour and recipe add 1 pound of nutmeg as a Fluent interface. So the first thing I have to do here is to actually add grams and pounds to numbers in Ruby. Well, that's really easy to do in Ruby because Ruby has open classes. If you create a class definition for a class that already appears in the class path, it just reopens that class, allows you to add new stuff to it. And this is what that looks like. So when I say class numeric, numeric is one of the built-in types in Ruby. When I say that, there's already been a numeric class loaded on the class path, and so Ruby will reopen numeric and let me add new stuff to it. And the new stuff I'm adding here is a gram method, and what I'm doing is for my recipes, I'm keeping all the unit in grams, and self there is just the value of the numeric object that this is within. So when I call gram, if I call 3.gram, it's just going to return 3. Because in Ruby, the last line of any method is the return value for the method. Ruby also has a really nice mechanism called alias method. I want this to be really nice and fluent. I don't want the people who are consuming it to have to say 4.gram. They would rather say 4.grams with an S. And so I create an alias method here that says anytime you call grams, just turn around and call gram for me. So if I call 4.grams, it's the same as calling 4 gram. I do the exact same thing with pound down below. And it turns out that a pound is 453.59237 grams. So that's what I'm returning for pound, because I'm keeping everything in grams internally. And then I have a bunch of alias methods down here, pounds, and then LB and LBS are also common abbreviations for pounds out in the world. So that's all you have to do to add the ability to have numeric values and units in Ruby. So that means that I've now solved the number part of this guy, the 200 grams, the 1 pound part. Now I need to attack this of method. Of is also going to be a method on numeric. Because remember, grams or pounds really returns a numeric of some kind. And so this is, again, going to be in the numeric class. So I have a method called of, which takes in an ingredient. Actually, it's very flexible. If you pass it and in a string, then it'll build you a new ingredient object. Or if you pass it a full-blown ingredient, it'll just use that one that you've already got. So that's what it's asking. Are you a kind of string? If you are, then I'll create a new ingredient. Otherwise, I'm assuming you've passed me one. And then you set ingredient quantity equal to self, because we're still in numeric here, and then return ingredient as the return value. Which brings up kind of an interesting point. When you look at a fluent interface like this, who returns what in this chain of method calls? One is an integer or numeric, and when you call the method on it, pound, it's a method call on a numeric, and it returns a numeric, because it's just returning a value, either a gram or pounds worth of value, which means that the of method has to be a method on numeric. And what it's ultimately going to return, it takes in a string parameter, and what it's ultimately going to return is an ingredient object. Sometimes getting all of these this chain of responsibility is difficult as you're writing the DSL. Ideally, for the people who are using your DSL, it should be very easy to understand. It should make sense in their problem domain. In fact, if it doesn't, then you've made a mistake, and you've done a poor job of writing your DSL. But this particular thing is so common, this kind of chained type inference, that there's a pattern name for this called type transmogrification. Transmogrification is probably not an English word that you know, because it comes from a comic book, Calvin and Hobbes, which is a comic book. Calvin, the little boy, has a cardboard box that he calls a transmogrifier, and he goes inside it and he becomes any kind of person he wants, superhero or caveman or whatever. So that's where this pattern name comes from. Transforming types is needed as part of a fluent interface call. It's also a very common thing that you see when writing DSLs. One of the goals of writing a domain-specific language is to make it really, really readable and writable. So you want to get rid of as many noise characters as possible. And Ruby obviously lets you do that because Ruby is a very flexible language with its syntax, so it'll let you skip parentheses and other sorts of what would be noise characters in a DSL. But here, in this particular version of my recipe, I've got some noise characters in terms of the double quotes around flour and nutmeg. And I'd kind of like to get rid of those. In fact, ideally, what I'd like to have is this. Have no double quotes around flour or nutmeg at all, and I can do that because everything in Ruby that begins with a capital letter, sorry, I'm having a fight with this water bottle. Okay. Everything in Ruby that starts with a capital letter is a constant. And in Ruby, anytime you try to access a constant that doesn't exist, it doesn't cause a stack trace and blue smoke to come pouring out the back of your computer and all that other stuff. It falls into constant missing. And then within constant missing, you can do whatever you need to do to rectify that problem. And so here's an example of creating a constant missing that anytime you call a constant that doesn't exist, it turns around and says, okay, we'll make that an ingredient object. This takes in a symbol, and then it just basically just says create a new ingredient based on that symbol. And this is another pattern in Ruby, constant missing factory. Use missings as factories to create types as needed so that you can use uppercase letters as the first character and then let the constant missing factory solve that problem for you. But there's a problem.